for solving polynomial equations. And let's start with easy stuff. What if I ask you to solve a linear equation? If I ask you to solve ax plus b equal to 0, is that super easy to solve? Yeah. Subtract the b over, divide the a over, you're done. If I ask you to solve ax squared plus bx plus c is equal to 0. Yes?
Could you put the
Oh, yeah.
Thank you.
Yeah, all I wrote down is a linear equation and the one easy. A quadratic equation, is that easy to solve? I guess it depends on exactly what you mean by easy. Sometimes there can be like some complicated computation, but there's a formula. What about a cubic equation? What if I just asked you to solve ax cubed plus bx squared plus cx plus d equals 0? So certainly, you've probably never seen a formula that gives solutions to such an equation. One exists. In the 1540s, a mathematician by the name of Cardano produced a formula that solves any cubic equation. It's a very complicated formula, and you'll notice that at no point will I write it down. If you want to parse through, say, well, if you go down to the bookstore and check out the book that's used for the history of maths class, it'll give you the formula and even an explanation of it. It'll be a couple pages to write down what the formula is and the explanation. You can try to read the Wikipedia article, but it's pretty dense. The formula is hard to use. So I won't bother giving it at all. There's a degree 4 formula that takes up even more space to write. Even just writing it down formulaically won't fit on a sheet of paper. It was come up with about a decade after that. And then it stalled out. No one could go up to degree 5. And in fact, what happened is much later, a mathematician by the name of Galois proved that, in fact, there is no hope. You cannot solve every polynomial equation of degree 5 or higher using purely algebraic means. That means you can't write down a formula that uses the coefficients and any combination of plus, minus, multiply, divide, exponentiation, and roots to produce solutions. There is no such a solution. And in fact, he proved specifically no amount of purely algebraic stuff will even solve that polynomial. In a bit of history, which maybe you'll find amusing, Galois was also a political provocateur. He was a controversial figure in 1800s France. And it says that, as I wrote down, he died in a duel. The person who killed him in this duel was a professional sharpshooter who conspiracy theorists will say was paid off by the French government to provoke Galois into challenging him so that he could kill him legally. So, don't accept any duels. And don't challenge anyone to a duel. You might be being tricked. Okay, so, disheartening as it may be, there is no hope of always solving every polynomial equation and finding exact answers. Do you think, so this very polynomial equation, do you think we could estimate solutions to it? Yeah, how would you want to go about doing that? Sure, guess and check. And a fancy name for how you would guess and check is you would maybe even just try to graph. You could get like an estimate for where the solution is, and you can zoom in as well as close as you want. You'll never get the exact answer doing that, but you'll get as many digits in the decimal approximations. Do people want to do that? Is there demand? Yeah, we've done that enough. So other than graphing, which can be approximate, there will just be some tricks that give exact answers sometimes, and sometimes they just say, oh, no, this trick doesn't apply. I don't know what the solution is. So let's try to develop some of those tricks, and here's the first one. If you know one solution, you can make the equation easier to solve by 1. And let's see that in practice. So here's a polynomial equation. 2x cubed minus x squared minus 7x plus 6 is equal to 0. I claim, I'm giving you the information that x is equal to 1 is a solution to that equation. Do you think we could check that really quickly? Yeah, so I've given you that it's true, but I often say things that are wrong, so let's not just trust me. Let's check. So let's plug in x equals 1 and see what we get. So plugging 1 into a polynomial is like really easy. Every power of 1 is just 1. So we'll get 2 times 1 minus 1 minus 7 times 1 plus 6. Does that equal 0? Cool. So 1 is actually a solution. And here's the payoff. If you know that 1 is a solution to a polynomial equation, then it follows automatically free of charge that x minus 1 will divide evenly into it. And so here's the game. If we can write down, so that means we should be able to write down 2x cubed minus x squared minus 7x plus 6 as x minus 1 times something. So let's see. What's the degree of this polynomial we started with? 3, I guess? So what must the degree of the question mark be? 2? Oh, cool. Degree 2 polynomials are easy to solve. I know what the solution to this is. It's 1. If I can find the solutions to question mark equals 0, then I'll be done. If I can just figure out what question mark is, then I'll have a complete plan of attack. So let's try to do that. So I guess that means I need to figure out how many times x minus 1 divides into that polynomial. And let's see, there's one algorithm to do it. It's called polynomial long division. In the case of dividing by a degree 1 polynomial, it turns out to be the same as a thing called synthetic division. So let's just see a show of hands. If I say polynomial long division, how many people already know that algorithm? Okay. When I say synthetic division, how many people are familiar with that? Cool. So what I think I'll do right here is I'll do polynomial long division. It'll take up lots of space, but you'll see everything that's going on and you'll understand what everything means. And then I'll also do synthetic division, which really just amounts to taking polynomial long division and erasing all of the information that's not absolutely relevant to the algorithm. So you won't be able to tell what any of it means, but you'll get an answer. So let's do polynomial long division, then we'll do synthetic division. So polynomial long division looks just like long division. I want to see how many times x minus 1 divides into 2x cubed minus x squared minus 7x plus 6. And it'll run pretty similarly to how long division works. So look at this biggest term, this x term. What would you want to multiply this x term by to get 2x cubed? 2x squared. So 2x squared. And then just like long division, you take this and you multiply it by that and you subtract it from the thing underneath the box. And that tells you what the next step of division needs to be. So take this, multiply it by that, and subtract it. So 2 times x, 2x squared times x is 2x cubed, and I need to subtract it. Then I'll need to subtract 2x squared times negative 1. So there will be a double negative, it'll get added. Everyone okay so far? Okay. Does anyone want to ask me questions about why the positive and negative signs are what they are? Okay, good. So let's do just normal long division really quickly. So what if I asked you to divide 7 into, I don't know, 526. Let's go through and try to do it by using just long division. Does 7 go into, how many times does 7 go into 5? Doesn't. How many times does 7 go into 52? 7 times. And then you say, well, 7 times 7 is 49, and you need to subtract it. Let's see, the remainder of 3. Carry the 6 down. 9 times does 7 go into 46? So this subtraction is exactly what's going on in there. And maybe I'll even go off to the side. I have space. So I want to divide x minus 1 into, and I only write the top couple terms, 2x cubed minus x squared dot dot dot. You already told me I need to multiply it by 2x squared. So that means I need to multiply this by that. So it'll be 2x squared times x minus 1. And I need to subtract that for the same reason as you subtracted here. And then you would distribute everything out, including that negative sign.
Okay.
And hopefully you would get the positives and negatives that I wrote to the right. Was that helpful?
Yeah.
Okay, good. Okay, but now let's just keep on trucking. Negative x squared plus 2x squared, so this is just like this subtraction happening. That leaves me with x squared left over. So now, my initial guess for division was 2x squared. Yeah.
Are you subtracting 2x squared though, instead of adding it?
Ah, so let's see what's down here. So I'm subtracting negative 2x squared.
Okay.
So that would be the same as adding 2x squared. So if we expand this out, we would get minus 2x squared x, 2x cubed, minus negative 2x squared. That would become plus. Is that helpful? Yeah. And the subtlety in doing polynomial long division is keeping track of signs. But let's see, so now I'm left with this x squared. So what do I need to multiply the top degree piece of x minus 1 by to get x squared? X. So the next term in the division, in the result of division, will be x. 2x squared plus x. And now I'll repeat. I'll multiply this by x minus 1, and I'll subtract the result. So I'll get minus x times x is x squared, minus x times negative 1. So that's plus x. And now keep on going. Negative 7x plus x leaves me with 6x, I guess? So what do I need to multiply x by to get 6x? 6. No. Yes. Yes. Okay, so same question. The answer is negative 6. Like I said, the difficult part about doing polynomial division is keeping track of all of the signs. So now I'll do it again. So I need to subtract negative 6 times x. So I'll subtract negative 6x. That's the same as adding 6x. And then I'll subtract negative 6 times negative 1. So that's like 3 negative signs in a row. So that reduces down to 1. Negative minus 6. All right, well, negative 6x plus 6x, that gives me 0. That's what it needs to do. Plus 6 minus 6 also gives me 0, so there's a remainder of 0. And I'll write down what information, so I'm intentionally leaving this side slightly empty. Because I'm going to write down what this means. So what does this mean? That means 2x cubed minus x squared minus 7x plus 6 is equal to x minus 1 times 2x cubed minus x squared minus 7x plus, no, x minus 1 times the thing on the top. 2x squared plus x minus 6. And I want to set all of that equal to 0. And I'll come back and do this more quickly using synthetic division. Actually, so maybe I'll give you guys, I'll do it either way. How many people would like right now to just solve this equation now that we've done the division? Okay, let's do that. Then I'll come back and do synthetic division, and we'll see. It's just a shortcut way of doing this same walk. Okay, so I'm setting this equal to 0. I see two things multiplied together, giving me 0. The only way a product can be 0 is if one of the factors is 0. So that means it must be that x minus 1 equals 0, or 2x squared plus x minus 6 equals 0. Everyone with me right now? Good. What's the solution to x minus 1 equals 0? X equals 1. That's easy, but it's also not exciting. That's the root that you started by just knowing. So we haven't learned anything yet. But this equation is now easy to solve. Or x equal to, let's see, negative b plus or minus the square root of b squared minus 4 times a times c. Oop. C is negative 6. All over 2a. Nice. So we have all of the roots. Do you think that that complicated one probably should be simplified? Yeah. Do people want me to do the simplification? Okay, seeing at least one head nodding, let's do it. So, let's see. Double negative becomes positive. Let's absorb that first. Equals negative 1 plus or minus square root of, let's see, 2 times 6 is 12, times 4 is 48, plus 1 is 49. All over 2 times 2 is 4. What's the square root of 49? And now we can write down what the two of them are. Negative 1 minus 7 is negative 8, divided by 4 is negative 2, or negative 1 plus 7 is 6, divided by 4 is, oh goodness, 3 halves, or 1.5. So we have all of the solutions. X equal to 1, negative 2, and 1.5. Yeah.
So this might not even be anything, and I don't know, maybe I got lucky, but I just factored out like x plus 2 and then 2x minus 3.
Oh, okay. You took like this piece and just factored it?
Yeah.
Yeah, that's cool.
Oh, okay.
Yeah. Yeah, there's, just because we have one way of solving degree 2 polynomial equations doesn't mean we don't have
So we're not like forced to do
the quadratic formula if you don't want to. Yeah. Yeah, if you get here and you can say, oh, well, I can factor that thing, do it. So let's also just go through synthetic division, which I'll tell you what to write down for synthetic division, and that's it. So whenever you want to divide a linear polynomial into another polynomial, and this linear polynomial has leading coefficient 1, somehow like that number is all that matters. And so here's what we'll do if we want to do synthetic division. I'll draw a 1, and then I'll write, so a 1 because that was a negative 1. So I made that negative 1 positive. You always just make it negative from what it was. And then I'll write the coefficients. 2, negative 1, negative 7, 6. And here's what I'll do. This 2 I'll just carry down. And that's because, well, what was the first thing you did? You said, well, what do you need to multiply by to get 2x cubed? Well, it was that 2. This 2 is exactly that 2. Next, I'll multiply 2 by 1 and add it. Here, which will give me 1. And notice that 1 is exactly the same as the 1 in front of that x squared.
And then I'll repeat. 1 times 1 is 1, so I'll add 1, giving me negative 6. 1 times negative 6 is negative 6, leaving me with 0. So here are the digits that I'll need to remember. And what does that say? This tells me that the result of division will be 2x squared plus x minus 6, which hopefully is exactly what we got by doing polynomial division. Yeah. And so the upshot with synthetic division is that algorithm took like 6 seconds to do, but you had no idea why I was doing it. Polynomial long division is slower, takes longer, but you can tell what's happening. I don't think I'll post to the webpage for today as a discussion of what synthetic and polynomial long division are and why they're the same. It'll be a really long document that will have all of the details, and it'll take a while to read. Any questions right now? Cool. This is supposed to be a no packet that takes about 2 days, so I'm okay with where I am time-wise. All right, so let's keep on going. Would we like to do another example of this? No. I would like to anyway. So let's do it. So let's find all of the solutions to x cubed plus x squared plus x plus 1 is equal to 0, given that x equals negative 1 is a solution. So I guess first things first, plug in x equals negative 1. Do you actually get 0? You do, I hope. As a consequence, you know that x plus 1 should divide evenly in. Well, maybe I'll give you guys the choice. Long division or synthetic division? Long division? Synthetic division. Oh, okay, I guess that's pretty unanimous. So let's do synthetic division. I'll write down this negative 1. And then I'll write down this list of coefficients. So I guess the coefficients are 1, 1, 1, and 1. And if you see that written down, then you have no idea what it means, but we're just remembering what it means, I guess. So the first thing I do is I just take this digit and carry it down. Then I take this and multiply it by that. Add these two together and get 0. Then I take this and multiply it by that to get 0. Add these two together to get 1. Then finally I take this, multiply it by that, get negative 1. Add those two together to get 0. And as written, what is there is totally unintelligible until you write down what the conclusion is. What does this mean? This means that the polynomial I'm interested in, x cubed plus x squared plus x plus 1, is equal to x plus 1 times, now I'll read this off, x squared yeah. Okay, cool. So now we'll set that equal to 0. Is this equation now super easy to solve? What are the solutions? Well, from this I see x equals negative 1. From this I see x squared equals negative 1. What are the solutions to x squared equals negative 1? Plus or minus I. If I had specified only real solutions, I would say there are none, but there are complex solutions. So it looks like x is equal to negative 1, or plus or minus I. How does that seem? That seem okay? I think I want you guys to do the next one. I'll give you some setup. So let's find the solutions to 2x cubed minus 10x squared plus x plus 5, given that x is equal to find is a solution. So if you want to use synthetic division, which apparently everyone does, that means you need to draw this string of symbols: 2, -10, -1, 5. And sorry, I just want to be quiet for a bit and let you guys do it to see if you follow the algorithm. I know you guys absolutely hate talking at all during class, but you can compare the result of division with those around you. Cool. So, well, do people want more time? I didn't actually give you much time. Okay. So, how does this polynomial factor? It is x minus 5 multiplied by Is that what I heard? That agree with everyone? Cool. I didn't do it, so maybe I'll say this. I don't believe you, but I don't want to do the hard work of doing the division. Do you think I could check that by just multiplying them together? Yeah, I'll multiply them together, and I'll see what I get. First, 2 times x is 2x cubed. So far, so good. Outside, minus x. The coefficients will be in, the things will be in the wrong order. That's okay. Minus 5 times 2, minus 10x squared, plus 5. Yeah, that's the same as I started with. Now I believe you. All right, cool, but that's not what I wanted. I wanted to set this equal to 0 and solve. Is that easy to do? Yeah, what are the solutions? I'll write down one of them. Yeah. And that's absolutely right. As we go on later on Jumo algebra, I'll say that I would want this simplified. I'll do that simplification. That's plus or minus 1 over root 2. That's the same as. But I'll say I don't want to ever see a square root in the denominator, so I'll multiply and divide by root 2. Now in the bottom, I see the square root of 2 times the square root of 2. That's the square root of 2 squared, which is 2. The answer you gave me was still the correct answer. How do people feel about that? That seem okay? Any questions right now? All right, so what is the takeaway? The takeaway is if you know one solution to a polynomial equation, then you can use that solution to simplify that polynomial equation to another polynomial equation which is simpler by degree 1. So if you know one solution to a degree 4 polynomial equation, that means you can reduce it to a degree 3. If you find another solution to that, you can get it down to degree 2 and you can use the quadratic formula. But there's a catch there. You need to know a solution. If you don't already know a solution, then you're stuck. And we know there's not going to be a purely algebraic way of solving these. So the best we can do is maybe a systematic way of making guesses. And here's the first set of guesses that I'll try to make. Let's try to determine all of the possible rational numbers that can be roots to polynomial equations. Right, because you would like say, well, let's try to plug in 1, then 2, then 3, because those are easy to plug in. But let's systematically say exactly when those might be roots, because then we'll know what whole numbers or rational numbers to even try to plug in. And let's do it for this particular polynomial. 2x cubed plus 11x squared minus 7x plus 6. Let's imagine that that has a rational solution. Then we'll try to cut down what p and q can be to a finite list. A rational solution p over q. We may as well assume that it's in reduced form, so p and q are coprime. There are no common factors. Then if I just make that substitution and add 6 to the other side, I should get this equation. Fair enough. Let's just take that equation and try to see what we can say about p and q. Does that look like, oh, I don't know, we could clear that denominator and get something simpler looking? Yeah. All the denominators have q's in them. It's multiplied by the biggest power of q is equal. Let's multiply everything by q cubed. So that'll give me 2p cubed minus 11p squared q minus 7p q squared is equal to 6q cubed. That seem okay? And certainly that's like a correct thing to do, but I haven't told you why I did it. I'll show you why I did it right now. So look at the left-hand side. Do you see any common factor amongst all of those things? Something you could factor out? P. Maybe we'll even do that. It doesn't matter how it factors. But we can factor out a p times, let's see, 2p squared minus 11pq minus 7q cubed is equal to this. So this number p divides the left-hand side, and it's supposed to be equal to the right-hand side. So if the left-hand side is equal to the right-hand side, then p has to divide the right-hand side. So that means p divides into 6q cubed. Yeah. Doesn't matter, but you're right. Did I at least say squared or did I say cubed?
You said cubed.
Okay.
I was just wondering where it came from.
No, I just came from the mistake. So this number p has to divide into 6q cubed. And p and q are coprime. So could p have any factors in common with q? Can't, right? They're assumed to be coprime. So p has to divide into 6. How many whole numbers divide evenly into 6? Oh no, maybe this is better. What whole numbers divide evenly into 6? Not very many. So that tells us something. If we have a rational solution to this polynomial equation, the numerator must be 1, 2, 3, or 6. That seems useful. Do you think we could also figure out what q might be? So what do? I'll take exactly this same equation. I'll take all of the q's and I'll move them to the other side so I can play that same game. So I'll end up with 2p squared equals, and I know this is going to be annoying because I'm going to be flipping back and forth. Well, maybe I should just write it down. 2p cubed minus 11p q squared. Did I copy it down correctly? Okay. I'll move everything to the other side. So that'll give me 11p squared q plus 7pq squared plus 6q cubed. Now look at everything on the right-hand side. Do you see any common factors? Q. I won't do the factorization because apparently I'll screw it up anyway if I try. Q divides evenly into the right-hand side. But the right-hand side is equal to the left-hand side, so Q has to divide evenly into the left-hand side. So Q divides evenly into 2p cubed. And now we'll play the same game. Does Q have any factors in common with P? Well, okay, so the takeaway is going to be Q has to divide into 2. What are all the whole numbers that divide evenly into 2? 1 and 2. Oh, neat. So P has like 4 choices, Q has 2 choices. In total, there are like 8 choices. With an extra plus or minus sign, I guess that brings us up to 16. That's not that big a number. Let's just list all of them. So all the possible P over Qs. So P is 1, 2, 3, 6. Q is 1 or 2. Let's just list them all. So I guess that's 1, 2 over 1, 3 over 1, 6 over 1, 1 over 2, 2 over 2, 3 over 2, 6 over 2. Is there any redundancy in that list? I've already listed 1, so I don't need to list 1 again. And there's one other thing that I'm missing. I don't know if it's plus or minus. So those are all of the possible rational roots to this polynomial equation. I guess that's like 10 things? 1, 2, 3, 4, 5, 6, 12 things to plug in. If there are any rational solutions to this equation, it's one of those things. So one thing I know without doing any checking now is that 23 over 7 is not a root to this equation. I don't even need to try plugging it in. I know it will fail. So there are like 12 things to check. Do you think we could now just see if any of them actually are? Yeah, with the aid of a machine probably, because that's a lot of computation to do. Let's evaluate. And this might be close to the last thing that happens today. Those of you who have computing machines on you, pull them out and do some evaluation. So I'll evaluate the polynomial in question. 2 x cubed. Well, is that exactly what I want? No, it's not. Plus 11x squared minus 7x minus 6 at. What was one of the possible rational roots that we found? Do we get that the result is 0? Have we found a rational root? Awesome. So there's 1. Let's just x equals 1 walks. And there are 4 of them all at once. We'll evaluate this polynomial. X is one of those things. So it looks like -1 is no good. 10 is not 0. 1/2 is no good because I get 14 over 2. Is -1/2 a root? Looks like. So we're going back over here. And I do advocate using this evaluate command when you want to do lots of computations at once. Let's just check the rest of them. So that's 1, -1. I did 1/2 and -1/2. 2 comma -2. 3 comma -3. 6 -6. And then 3 halves -3 halves. So, in that list of outputs, I see 3 zeros. How many zeros do I expect this degree 3 polynomial to have? 3. So I found them all. It's just a matter of matching up now. So, the first one corresponding with the first entry, that's 1. 1, 1, 2, 3, 4, 5, 6, 7, 8. -6 is another one. And then the last one was 1/2, I hope? -1/2. Nice. So that was a complicated process we did to find that finite list. We can summarize all of that process in a theorem. I'll state the theorem. We'll use it once, and then we'll call it a day. So here's the statement. If a polynomial equation, there's a polynomial equation, it has high degree, equals 0, has a rational solution, something of the form plus or minus p over q, then p must divide a0. Let me put that into words. So the numerator is a factor of the constant term. And q must divide ad. The denominator is a factor of the leading term. Those statements make sense? So let's just apply that once. We may not have enough time to test them, but let's find that finite list. So let's find all rational solutions to 3x cubed plus 2x plus 2 is equal to 0. And here's how we'll do it. So apparently p has to divide into the constant term. What's the constant term in this polynomial? 2. So I'll use a notation that maybe you haven't seen before. P divides evenly into 2. What are the numbers that divide evenly into 2? 1 and 2. What are all of the possible values for q? Yeah, just say it louder. I guess it depends on, you have to put a plus or minus somewhere. I'll put the plus or minus in the next step. But you could put them right here. It wouldn't be incorrect. I wouldn't want to put them in both places, as the negative sign in the denominator is redundant. Not that it would be wrong to, it would just give you too long a list. So all the possible values for p over q is 1, 2, 1/3, 2/3, and well, what would you do next? You would plug these in, possibly by using some sort of evaluate command to limit the amount of data entry you have to do. And you would see if any of them are. Unfortunately, I don't think I can do that in maybe 45 seconds. So we'll come back, we'll pick this up next time. What is it?
This is just a huge sheet or whatever, just for clarification.
Oh, yeah.
If you don't want it.
No, I didn't. Yeah. Yeah, well, so that's for 27?
Yeah, well, we're leaving.
Oh, 6 months, okay. So you'll miss
Yeah,
tomorrow. Okay.
I'll miss tomorrow, yep.
Good. Check the webpage for notes.